Good afternoon. Well, I'd say good morning because it's 6:10 in the morning while I'm filming this, but that's okay. It's afternoon for you guys. This is a very quick, down and dirty review of systems of equations. I have posted several websites at the end of this just in case you do need further information, but I'm hoping that this is just a quick review. Take a look at these three equations. Can there be more than one solution to each of these equations? And the question I have to you is why or why not? And hopefully you notice that in the first one, that this is just an answer of x equals 3, the second one y equals 3, and the third one that x equals 4. And the reason why there's only one solution is because there is only one known quantity that could make each of these true. That is because you have a single variate or monovariate equation. Okay? Now let's take a look at something else though. What happens when I give you this? X plus y equals 12, m minus n equals 2, x times y equals 24, and y equals 2x plus 1. Notice that this is bivariate. Bivariate means you have two different variables. So is the solution the same if you have two variables instead of just one variable? And hopefully what you're going to say is no, Mrs. Rose. How many total solutions are there for the equations with more than one variable? Well, for the case of x plus y, if you're talking about the real number system, there's probably an infinite number of solutions. Okay? Now, please take a look with 7, 8, 9, and 10. Something we talked about last week is the difference between linear and non-linear equations. Hopefully at this point you notice that one of those equations that Mrs. Rose showed you as she bumps the tape is one of these, number 9 in particular, is nonlinear. Do you remember why? So go ahead and stop the tape right now and find 4 solutions for each of these equations and then start the tape back up so we can talk. Why did you write your solutions as ordered pairs? Is it possible to list every single solution to these equations? Well, typically when you see x and y, you think of the what? That's right, the coordinate plane. And so that's probably why you wrote them in ordered pairs. It is not possible to list every single solution to these equations because the x-axis actually is a real number line for x values, and the y-axis is a real number line for all of the y values. To show every solution to an equation with two different variables, you would show the solution set as a graph. Very good. So, show the solution to the equation y equals x plus 3 and describe in detail why it is the solution. Well, this is in slope-intercept form, so Mrs. Rose would just go here, and then she would go here, and then she would go here, and then she would go here. Now, if Mrs. Rose graphs the solution like this, I would say that this is an example of a discrete graph, okay? However, if Mrs. Rose draws the graph like this, let's try to fix that a little bit so it's a little bit easier. Remember that there is some distortion when Mrs. Rose uses the whiteboard. But if Mrs. Rose were to graph this like this, then she would call this a continuous graph. So I would like you to research those, and that is something that I want you to discuss for tomorrow. Look how horrible that circle was. Let's try to make that a little bit better here. That's your entrance slip for tomorrow, something we're going to talk about tomorrow. Let's talk about, make sure that you know the difference between continuous and discrete. Now, systems of equations, you have two equations, and you want to find the solution for the system. Usually, if you graph the system, what you'll do is, especially with linear systems, the point of intersection right here becomes the solution of this system. So this student states that the point 3, 4 is not a solution to the system, and they're absolutely correct. The solution would be the point of intersection. Now, please remember, though, as we continue with this slide, that there are a variety of solutions depending on the system. You can have one solution. You can have infinitely many solutions. Or you could have no solutions. All right? And here is the information that you might have. You really do need a card for this about the three types of possible solutions for systems of two linear equations. Please understand what consistent and dependent means. Stop the tape and make yourself your cards, and we'll talk about this some more in class tomorrow. Also, go ahead and take a look at this. This is a very typical thing that you might see on the 8th grade CRCT, where you're given a systems of equations and you're asked, is this a solution or is this not a solution? Now, let's not be lazy here. Remember that this is horrible, horrible math language, plug and chug, okay? Really and truly, what we want to say is substitute and evaluate. Now, what will happen with lazy children is lazy children will take the first point, substitute it in, and if it makes the first equation true, they'll say, oh, that's the solution. But that's not the case, guys. You have to make sure that you check it in both. So real quickly, we just do this and say, does that equal 14? And yes, case in point, 12 plus 2 does equal 14. Now, the lazy student will say, this is a solution, but don't forget, you also need to, that's right, substitute the last value in and say, is this equal to negative 2? And 6 plus negative 8 is indeed equal to negative 2. So yes, this is a solution. Go ahead and try the other two and see what answers you get, and we'll talk about that tomorrow. Now, to solve each system by graphing, and we're going to talk about this a lot in class. In order to solve by graphing, first of all, you have to make sure that your graph is not distorted. So doing this in a math journal is not exactly the best way to do it. But also, using the whiteboard can be difficult. You also have to make sure that everything is perfect as far as the precision goes. Okay? Again, here's a hint. At this point, Mrs. Rose is making a discrete graph, but since this is a systems of equations with linear models, she has to make the graph continuous. So she goes ahead and she puts in the first equation, and then she goes ahead and puts in the second equation. And while she's doing this, she can have a rough estimate right here that this is the solution of this equation. But please notice the distortion here. So I'm going to estimate that it's approximately negative 3, negative 1. But you can tell that if I do that and put this in here, negative 1, does that equal negative 6 plus 4? And the answer is no. So this is not the correct solution, even though it looks where my graph might appear. Go ahead and try this one, and we will talk about why graphing systems is not the best way to solve the solution. So, tomorrow, please have cards made for the following vocabulary terms. What is a systems of equations? And don't forget on the back, you should have the example. The three types of systems of equations, and discrete versus continuous. Hint, if you don't know this one, we'll start class with this one tomorrow. Now, for those of you who might need extra help, when you pause the end of this video, here are 4 very, very good websites that you could possibly use, okay, for definitions of systems and just in general how to get back into systems. Toodles, hope you have a great day today.